of adopting sustainable agriculture practice and membership in agricultural cooperative on farm productivity and also efficiency in this region. And also illuminate the transformative impact of information and communication technology such as smartphone on the subjective well-being of rural residents. Uh, Dr. Wanglin Ma, Professor Wanglin Ma has few journal and review article for more than 100 journal. According to the 2024 Economist ranking based on the past 10 year publishing at the IDS, Professor Wanglin Ma is ranked top 5 economics in New Zealand. Also, Professor Wanglin Ma has actively contributed to the economic discipline by serving as co-editor and associate editor for several reputable journals, such as Review of Development Economics, Annal of Public and Cooperative Economics, the International Journal of Agriculture and Resource Economics, and International Journal of Sustainable Development and Food Ecology. So by his experience, this is a great opportunity for us to learn how about the impact of evaluation, especially in agriculture sector. So without any further ado, let me invite Dr. Wanglin Ma to give a lecture about the impact evaluation, quantitative method, and application. For Dr. Wanglin Ma, time is yours.
Okay, thank you very much, Dr. Sodiq and Harry Toiba, and who invited me to join this session. So, good morning, everyone. You are welcome to my presentation. So, in my presentation, I will talk about impact evaluation, quantitative methods, and applications. So, in this 2-day session, I'm going to introduce some non-parametric approaches and 2 parametric approaches that will be used for impact evaluation. So definitely, Dr. Sodiq has applied some of them in his journal article writing. So I expect that some of these methods can also be used in your journal article writing or thesis writing for postgraduate students. Okay, so in my presentation, I have 2 sections. In section 1, I will talk about non-parametric approaches. So mainly I will introduce propensity score matching method, regression adjustment estimator, inverse probability weighting estimator, inverse probability weighted regression adjustment estimator, augmented inverse probability weighted estimator. And also I will talk about the assumptions, similarities, and differences of PSM, RA, IPW, IPWIA, and AIPW estimators. Okay, so these are different approaches, and they can be applied in different contexts. So after my explanation, you will definitely have a clear understanding on which condition you should use PSM or others. Okay, so here, another important thing I want to emphasize is for non-parametric approaches. In the applications, we do not need instrumental variables. Sometimes it's very challenging to identify valid instrumental variables. Therefore, we can apply for non-parametric approaches to do impact evaluation. For the parametric approaches, usually we have to use instrumental variables. So if you can find a valid instrumental variable, you can use the parametric approaches. So In this presentation, today and the 30th of July, I will mainly introduce these two parametric approaches, but I will also mention other approaches that can be used. Okay, so what to evaluate and why? Development programs and policies are typically designed to change outcomes. For example, to raise incomes and reduce poverty, to improve learning, or to reduce illness. So, for example, in your university, you have the invited speaker session. Like I'm invited to speak in your university to teach. Okay, so some students participated in the invited lecture section. Others are not participating in the session. So we can compare these two groups of students who participated in the invited lecture session and those who didn't in terms of academic performance. Or in a country, for example, the government implemented the microcredit program to help release capital constraints facing by smallholder farmers. So what we want to understand is whether accessing the microfinance can help improve their farm improvements. And also, whether or not these changes are actually achieved is a crucial public policy question, but it is not often formally examined. Program managers and policy makers focus on controlling and measuring the inputs and immediate outputs of a program. But it is important that they know whether program or program interventions have achieved their expected or intended goals. So the objective of this workshop or presentation is to provide an introduction to different econometric approaches that can be used for evaluation the effects of developing programs and policies. So for example, for farmers, some farmers are using extension services, others are not. So we can use the impact evaluation approaches to analyze whether access to extension services can help improve farm performance. Let's say, for example, whether farmers who accessed extension services perform better in crop yields or household income compared with those who did not access to extension services. So I'm just listing some examples here, but the approach can be used to analyze many research questions. So why should we learn different approaches to impact evaluation? Why is one approach not enough? This is because that sometimes it is difficult to find a valid instrumental variable in parametric estimation. No matter we have only one outcome variable or several outcomes, we have to use a non-parametric approach for impact evaluation. So for robust check, we also need to use an alternative approach for impact evaluation. That's why we need to learn different approaches for impact evaluation. So our interest of estimating the factors that affect the dependent variable. Okay, so here, let me give you more specific examples to highlight the importance of evaluating the program or policy intervention. Okay, so the first one is cooperative membership. Some farmers are members of cooperatives or associations, others are not. So we want to understand what are the differences in crop yields, farm income, household income, or adoption of agriculture technologies such as fertilizer, pesticides, and improved seeds between cooperative members and non-members. Also, we want to understand the difference in household income, subjective well-being, and adoption of agriculture technologies between farmers who participated in non-farm work and those who didn't. That is to analyze the impact of all farm work participation on household income, subjective well-being, and adoption of agriculture technologies. Or we want to analyze the microcredit program participation on household income, food expenditure, and poverty reduction. Or we want to analyze the effect of smartphone use on household income or subjective well-being. Because in city area, in urban area, almost all adults have a smartphone, but this is not the case in rural areas. Not all rural households have a smartphone. Have smartphones, so we can analyze the effect of smartphone use on household income or subjective well-being of users. We can still use the approach. So it is easy to estimate the impact of a treatment variable on the outcome variable if ideally it would be an experiment. But conducting an experiment is always very expensive. And random assignments to treatment groups. But in reality, participants and non-participants are not randomly assigned. Not randomly assigned, that means for example, for farmers, they self choose whether to participate in all farm work or not. No one forces them to participate in non-farm work. And also isolate the effects of treatment. So here we are facing challenges such as one often cannot conduct experiment because conducting experiment is usually very expensive, and we need equipment, we need land. And also one must rely on observational data. But in reality, some unobserved factors may also affect a person's, individual's choice. So for example, innate ability and motivation. Oops. Innate ability or motivation. Because usually people self-select them to be treated group or control group. Therefore, we need to use the impact evaluation approaches to do the estimation. So in the section 1, we will learn there's different non-parametric approaches such as PSM, RA estimator, IPW estimator, IPWRA, and AIPW. And also, I will explain the assumptions, similarities, and differences of those approaches. Okay, so the first part of section 1 is a theory introduction. Now let's look at PSM model. So PSM model constructs a statistical comparison group that is based on a model of the probability of participating in the treatment using observed characteristics. So participants are then matched on the basis of this probability or propensity score to non-participants. The average treatment effects of the program is often is then calculated as the mean differences in outcomes across these two groups. So usually we match program participants and non-participants using the probability model, or firstly we use the probability model or logic model to calculate the propensity score for program participants and non-participants, and then we compare outcome variables between participants and non-participants. The validity of a PSM depends on two conditions. The first one is conditional independence, namely that is unobserved factors do not affect participation. In other words, when we use PSM model, we do not assume the existence of unobserved factors. So what are the unobserved factors? As I explained previously, for example, individual's innate ability, motivation. And the second one is a sizable common support or overlap in propensity scores across the participant and non-participant samples. So the drawbacks of a PSM method is it fails to address the selection bias arising from unobserved factors. Different matching strategies can be used for propensity score matching approach. The first one is nearest neighbor matching. This approach is very common. And one of the most frequently used matching techniques is nearest neighbor matching, and where each treatment unit is matched to the comparison unit. Comparison unit means control group with the closest propensity score. And one can also choose n nearest neighbors and do matching. So that is usually n equals to 5 is used. Matching can be done with or without replacement. So matching with replacement, for example, means that the same non-participant can be used as a match for different participants. The second matching approach that is commonly used is called reduced matching. One problem with nearest neighbor matching is that the difference in propensity scores for a participant and its closest non-participant neighbor may still be very high. This situation results in poor matches and can be avoided by imposing a threshold or tolerance on the maximum propensity score distance. And this procedure therefore involves matching with a replacement only among propensity scores within a certain range. A higher number of dropped non-participants is likely, however, potentially increasing the chance of sampling bias. The third common approach is kernel-based matching. So one risk with the methods just described is that only a small subset of non-participants will ultimately satisfy the criteria to fall within the common support and thus construct the counterfactual outcome. And non-parametric matching estimators such as the kernel matching use a weighted average of all non-participants to construct the counterfactual match for each participant, which can solve the problem facing other approaches. So, other approaches can also used to match participants and non-participants. And these three approaches are just commonly used. And another thing I want to emphasize is when we apply propensity score matching in writing, we usually use at least two matching approach to calculate treatment effects. So although different matching approaches can be used to calculate treatment effects of a program intervention, in reality, we usually apply two or three approaches at the same time to calculate the treatment effects because the results estimated from one approach is not robust. We must use different approaches to calculate treatment effects for a robust check, usually 2 or 3 approaches. So we see another reason is each matching approach has its own advantage, but it also has disadvantages. Therefore, in reality, we usually use different approaches when we apply the PSM model for the purpose of results, comparison, and robustness checks. Okay, so here, suppose we want to analyze the impact of off-farm work participation on household income. So do you know what is, I guess everyone knows what is the off-farm work participation. Because previously, when I made a presentation in one university, some students have no idea what is off-farm work participation. So I assume all of you know what is off-farm work participation. No reaction. So do you know what is the off-farm work participation? Yes.
Participating in non-farm employment.
Oh yeah. So some farmers choose to work off the farm when they have time. So each year we have 12 months. So for non-participants, they are purely work on farm. For some farmers, they spent 12 months in off-farm work. Some farmers choose to work probably 3 months in a year for a part-time job. Okay. So here, if we want to analyze the impact of off-farm work participation on household income, so we have two groups of people. Off-farm work participants, that is a treated group. And we have non-participants, that is a control group. Is it clear? Okay. that are similar in terms of observed characters, thus reducing the bias that would otherwise occur when the two groups are similarly. Okay, so it involves two stages. Firstly, we generate propensity score. So for example, here we have two farmers. The first one is Destiana. Is the right name? Okay, so Destiana is a farmer who chooses to participate in non-farm work or all farm work. And we have another farmer, Ferdos. Is the right name? 我呼吁Ferdos.
Firdaus.
Huh?
Firdaus.
Ferdos.
Yes, it's correct.
Okay, so Firdaus is a farmer who doesn't choose to work off farm, and he's purely operating farm work. So in this case, Destiana choose to stay on farm for 9 months and choose to work off farm for 3 months. And Firdaus choose to purely work on farm. So in this case, Destiana is all farm work participant, and Firdaus is a non-participant. And we have two groups of people like this, so we can compare the differences in household income between these two groups of people. So because in reality, when we do the empirical analysis, we do not focus on two farmers. We focus on a sample with two groups of farmer. Okay. So firstly, we generate propensity score. That is the probability that a household head chooses to work off the farm using a probit model. Because Destiana chooses to work off farm, we can calculate the probability that Destiana chooses to work off the farm. And Firdaus does not choose to work off farm, but we can still calculate a probability that Firdaus chooses to work off the farm. Because Destiana chooses to work off farm, your probability of participating in all farm work will be higher. But for Firdaus, he did not choose to participate in all farm work. His probability of choosing to work off farm is low. Okay. So firstly, we generate a propensity score, and then we calculate the average treatment effects on the treated based on the estimated propensity score by Okay, so here the first stage is to estimate the probability that a person chooses to work off the farm. So here PRX1 is the probability, and CI equals to 1 is all farm work participants. Z1 is a vector of pre-choice characteristics. That is, for example, a person's age, gender, education level, household size. So for Destiana, whether you choose to work off the farm, and your decision is influenced by your age, by your gender, by your education level, by your household size, or something else. And for Theodos, he didn't choose to work off the farm. His decision is also influenced by his age, gender, education, household size. All these variables are controlled by Z. And then after estimating the propensity score, we can match participants and non-participants based on the observed characteristics and compare the outcome variable. That is the second step. Okay, so is it clear for the propensity score matching method? Now let's look at the RA adjustment estimator. So RA estimator models the outcome to account for the non-random treatment assignment. RA estimator models the outcome without any assumptions about the functional form of the probability of treatment. So for example, if we want to analyze the effect of all-farm work participation on household income, all-farm work participation is a treatment variable, and household income is an outcome variable. When we apply RA estimator, and it models the outcome variable. That means it assumes the specific it assumes the correct specification of the outcome variable. It does not have assumption about the correct specification of the treatment variable, treatment model. Okay, so what is IPW? So IPW estimator models the treatment to account for the non-random treatment assignment. IPW estimator models the probability of treatment without any assumption about the functional form for the outcome model. Did you see the differences? So RA estimator only models the outcome equation, and the IPW estimator only models the treatment equation. Okay. The third approach or fourth approach is IPWRA. IPWRA is inverse probability weighting with a regression adjustment. So IPWRA estimator models both the outcome and the treatment to account for the non-random treatment assignment. Did you see the differences here? RA estimator models the outcome variable only, and IPW estimator models the treatment equation only, while IPWI estimator models both the outcome and the treatment equations to account for the non-random nature of the treatment assignment. And IPWRA uses IPW weights to estimate corrected regression coefficients that are subsequently used to perform regression adjustment and to compute potential outcome model. And because IPWRA estimator combines both models for the outcome and the treatment status. It is doubly robust. So did you say this? For among IA, IPW, and IPWIA estimators, among these three approaches, IPWIA is better. And then let's look at the AIPW. AIPW estimator refers to the augmented inverse probability weighting estimator. AIPW estimator adds a bias correction term to the IPW estimator. So if the treatment model is correctly specified, the bias correction term is 0, and the model is reduced to the IPW estimator. And if the treatment model is misspecified, but the outcome model is correctly specified, the bias correction term corrects the estimator. So AIPW estimator models both the outcome and the treatment probability. And the bias correction term gives the AIPW estimator the same double robust property as IPWI estimator. So from the explanation here, we can see IPWRA and AIPW estimator have the similar attributes. In reality, they can be used together. They can be used for robustness check. Okay, so here, what are the similarities and differences of non-parametric impact evaluation approaches? So for PSM model, we can estimate ATE, ATT, and ATU. For RA and for RA, IPW and IPW-RA estimator, we can estimate ATE and ATT. However, for AIPW, we can estimate ATE only. And for IPWRA and AIPW estimator, they have a double robust nature. So which approach did you use, Sodiq? IPWRA?
IPWRA.
Did you use AIPW before?
No, I haven't used AIPW.
Yeah, did you use the PSM before?
Yeah, PSM, IPWRA. Only two approach that I use.
Yeah, that's great. And so here, clearly we can say if we use IPWRA to estimate ATE, we can use AIPW estimator for robust check. However, if we use IPWRA estimator to estimate ATT, we cannot use AIPW because for robust check, they should be the estimation should be the same. Okay, so do you have any questions so far? Do you have any questions so far?
I think Harry have a question. He in the chat box, Professor. About
Oh, by Professor Harry Toiba. Not Toiba. I clearly remember Toiba is a river, so his name is Toiba.
Toiba.
Is it correct?
Yeah, it's correct.
Okay, PSM reduces the effect sample size, but disgusting units that do not have suitable matches. In this case, the sample treatment were limited. How to overcome the cases? Okay. So because as I mentioned, we have different matching approaches. If we use one-to-one matching, and the sample size will not be reduced. If you have a larger sample size, you can use any approaches. However, if you have a small sample size, it's better to use one-to-one matching. Because for the nearest neighbor matching, we can choose 1-to-1 matching, 1-to-2 matching, something like this. Yeah, we can decide it in estimation. Okay, so do you have any other questions so far?
Another question from student. If you have any question, you can turn on your microphone or your raise your hand.
Okay, so we have both students and staff
Firdaus,
in
do you
this
have a
presentation.
question?
Hmm?
Yes, Mr. Sudik.
Yeah. It's one question.
Good morning, Mr. Wanglin Ma. I have a question for the SM.
Yes, please.
Uh, in
Firdaus.
estimation, yes. In estimation, we use SM to measure the impact of climate change inflation on subjective well-being. We use method multivariate probit, which means there are many education strategies that farmers can use.
Pardon?
Example, the farmers use irrigation and any adaptation. Now, in some case, that I analysis uh, only use a dummy treatment variables, yes or no.
Mm-hmm.
So in PSN, we can use treatment variable like multivariate probit. Now, if not, how can this be addressed?
I didn't get your question clearly. You are analyzing, so Sodi, could you please help to rephrase?
Okay, Professor, I think in my Firdaus asking about if the farmers having a multi-adoption.
Oh,
For instance,
multi-adoption, more than two.
yeah,
Yes.
yes.
Oh, yes, and I will mention the approaches later. So, in that case, we have two approaches. The first one is a non-parametric approach, that is a multi-valued treatment effects model. The second one is a parametric approach. It's called a multinomial endogenous switching regression model. So those two approaches can be used if farmers have more than two choices. Yeah, and I did not include those two approaches in the slides, but I think I have one slide to mention those approaches. Yeah, okay, great. Any more questions? Yeah, I think let's have a 10 minutes break and then we will look at the practices. Okay? Okay, great. And let's
Okay,
come
great.
back. Yeah. Okay, see you later.
Oke, istirahat 10 menit.
Hello? Oh, I couldn't find my screen. Oops. Okay, so sorry, I'm a little bit late. Yeah, someone just came to talk with me. Okay, so now we need to do some practices. I'm not sure whether all of you have installed Stata on your computer. Do you have a Stata on your computer? Yes. Or definitely
Yes.
Zotic, yes, because you're analyzing you're analyzing the data using the Stata. Okay, so firstly is to calculate propensity score. So this is the command propensity score. All farm work is a treated variable, and then we have a control variable. So in your analysis, you can include variables, control variables. You have interest. And then the second stage is to calculate the ATE or ATT using different matching approaches. So for example, for the nearest neighbor matching, we use ATT-ND. Or we use kernel-based matching, ATTK, or reduce matching, ATTR. You say ATT means ATT, R means radius matching, and ND means nearest neighbor. Okay, so these are results generated for the first step, and these are results generated for the second step. I think if we open our data set and we can do the calculation. Let me check which one we should use. So can you just because you got the all farm work data, so can you just practice these commands? PS score. All farm work. Can you please try? Okay, so if PS score does not work, you should install it first. So did you get the results?
Yeah, I get the result. The result.
Okay, yeah, because I'm not sure whether others can use PS score.
I think some of our master students get the result as well.
They get the
Firdaus,
results also.
yeah. Firdaus, did you get the result?
Hmm?
No, Firdaus. Chowki.
Wait, wait.
They are master students or PhD students, Sodiq.
Master student.
Oh,
Some also we have PhD student who join us here.
oh.
Think ourselves.
PS score is not. Oh, for household size, probably you need to add E.
Oh yeah.
Yeah, E is missing in the slides.
Yeah. Yeah, I get it. Yeah.
My PS score does not work because I moved to a new computer this morning.
Oh, so you need to install it first, right?
I installed it, still it doesn't work. I don't know why. PS score. SSC install. PS score. It seems I have it now. Okay, so here COMSUP refers to common support.
Oh.
Okay, so I get my results. Did you get it?
Yeah, I get it.
Yeah, okay, so here we have it.
I think, Professor, I think not all of our participants have installed the PS4. Can you show them how to install the PS4 first? Because
Oh
in the
yeah.
chat box,
Okay,
yeah.
so you type SSC install PS score and then search PS score. If it does not come out, you just search PS. Do you have any students who come from Bali Island this year, Sodiq?
I think we have here from Bali Island.
Oh yeah, that is a very beautiful place. My wife really wants to visit that very beautiful.
Yeah, just come to Indonesia and then you can visit Bali also.
Have you visited Bali Island?
Sure, I have.
Huh?
Yeah, I have, Professor.
Okay. So did you see it? PS score. So here you clicked this one. Click here to install. Did you see it? If this one does not work, You try the second one. Bali Island. Oh, how lucky the student is to be grown up in Bali Island. Yeah. Do all students get the results now?
You get the
Okay.
result, guys?
So drop. Drop means delete. This one, this one, this one. So we can re-estimate. Can you see it? So this result, you say, from this result, we can identify the factors that influence farmers' decisions to participate in all farm work. And then we can calculate the treatment effects using the different matching approaches. Have you tried them? Bali, Bali, Bali. You say this is the nearest matching. Did you see the results? ATT means average treatment effects estimated by nearest, did you say nearest neighbor method? And oops. Yeah, this is ATT. Oh, there's a small error here. Okay, anyway, you know how to do the estimations. Did you see it? This is a radius matching method. Okay, great. The good thing is you know how to do the estimations. Do everyone get the method for the estimation?
Yeah, we have a similar result, Professor.
Okay, great. So here, yeah, these are results, and these are other methods that can also be used to calculate ATT. So you can practice this at home. Okay, so here did you say logit? Here, logit. If you do not add logit here, by default, the model will be estimated by probit model. Okay, so I'm not sure whether you need to install PSM match. Let me try. So do you have to write master thesis in Indonesia?
Yeah, of course, Professor. We need to write master thesis and publish journal as well for
Oh,
our
you
master
you
thesis.
need to publish.
Yes.
Yeah, my computer is quite slow. Did you see CAP here? It is running.
You need a new computer, I think.
No, not the issue of a computer. My version for data is the lowest. That is BE. Did you see it?
Oh yeah. It's the
Yeah, I should ask a university to buy a better one. Okay, so I would suggest that you do not copy paste the variables directly because I found E after Z is missing here. Did you see this one? It's better to find the variable by yourself here. So for this variable, it's better to type it by yourself. Okay, so for PS match 2, how do you install it? SSC install PS match 2. Yeah, did you see? This is the install new commands. Okay, so now let's try RA estimator. Did you get the results, Sodiq? My computer is extremely slow.
I get the result, Professor.
Yeah, so which version are you using for Stata BE, SE?
SE?
You are using SE.
Yeah, SE. But it is individual license.
Individual license. Please check whether other students also got the results, Sodiq.
Okay. Firdaus? Tauki udah dapat?
Yes. Betul.
Tauki?
Okay?
Okay. They are getting the result. Do
Okay,
Rizky dapat?
great. So
Do
previously
Rizky?
we said RA estimator can also be used to calculate ATE or ATT. So in this case, we calculated the ATE. So could you please change ATE to ATT and see what it looks like?
ATT is not load.
Did you try ATT?
ATT is not allowed.
ATT is
Okay.
not allowed.
Yes.
Oh.
Ano? Uh,
Oh, option ATT is not allowed. Okay, let's try it in this way.
this also show ATA, Professor.
Oh, ATE, yes. I don't know why ATE is oh, I know. You should try ATET.
Mm.
Did you see it?
Yeah, I get it.
Oh, yes, ATET. So this is the RA estimator. Okay, so next stage, let's try which one? Okay, so let's try IPW. ATET first. It works.
Yeah, it's perfect.
And also try ATE. Yeah, my version is very, very slow. Let me check how much data price. Do you see it? Oh yeah, I think I should use MP. Okay, so you have tried ATT and ATE. Now, could you please try IPWRA? ATET and ATT. Did you see it? And ATE. Did you see it? Excellent. And also, can you try AIPW? AIPW can only estimate ATE, and it cannot be used to estimate ATT. All good?
Good, Professor.
Yeah. Okay, so let me explain key points related to each estimators. Firstly, for the RA estimator, and independent variables do not appear in treatment equation because RA estimator models the outcome means outcome variable. So PCHH income, that means per capita household income. Because RA estimator models the outcome without any assumptions about functional form of the probability of the treatment variable. So this is the treatment variable. This is a treatment model. This is an outcome model. And the estimated treatment effects is the average treatment effects by default. If you want to estimate average treatment effects on the treated, you need to add a command ATET in the end. For AIP estimator, it is different. So for the AIP estimator, the independent variables do not appear in the outcome equation because IPW estimator models the probability of treatment without any assumptions about the functional form of the outcome model. The treatment equation is estimated by a logic model by default. You can decide whether you want to use a probit or a logic model by yourself. So here you can type either probit or logit. So can you please try to replace logit with probit and see the differences? Ferdos, are you a student?
Yes, Professor.
Where are you from?
In Pamekasan City.
In Pamekasan City.
Yes. Yes, Java.
Oh yeah. It must be a very nice city. So can you please try the estimation T effects IPW to replace, you only replace logit with the probit and see the differences of the estimated results. Did you try? Yes. Okay, so did you see the difference between AIP and RA? So in RA, we include the control variable in the outcome equation. And in the AIP estimator, we include the control variable only in the treatment model. Did you see the differences? Yes.
Yes.
Okay. And then the estimated treatment effects is average treatment effects by default. If you want to estimate average treatment effects on the treated, you need to add a command ATET in the end. If we do not add ATET, it will estimate ATE. Okay, excellent. Now let's look at IPWRA. So for IPWRA, because it has a double robust nature. So when we do the estimation, you see the same control variables are included in the outcome equation and the treatment equation. So you can decide the outcome variables and treatment variable as well as control variables in your estimation. Okay. Yeah, okay. So the independent variable appear in both the treatment and outcome equations. And the IPWRA estimator models both the outcome and treatment to account for the non-random treatment assignment. And it has a double robust property. It has a double robust property. That means IPWRA estimator is better than RA estimator and IPW estimator. Is it clear? Excellent. So the treatment equation is estimated by a lodged model by default. You can decide whether you want to use a probit or a lodged model by yourself. Because usually in the first stage, we need to calculate the propensity score and identify the factors that influence farmers' decisions to participate in all-farm work. So if you use logit in the first stage estimation, when you generate the factors affecting farmers' decisions to participate in all-farm work, using the lodged model. Here, you should consistently use lodged model. The estimated treatment effects is average treatment effects. By default, if you want to estimate average treatment effects on the treated, you need to add a command ATET in the end. Okay, so finally, it is a AIPW estimator. So the independent variables appear in both the treatment and outcome equations. And IPWRA estimator models both the outcome and the treatment to account for the non-random treatment assignment. And it has a doubly robust property. So both AIPW and IPWRA estimator and AIPW estimator have a doubly robust propensity. So they can be used for robust check if we only estimate ATE. The estimated treatment effects is average treatment effects by default. Average treatment effects on the treated cannot be estimated by using a AIPW estimator. This is different from others. Okay, so these are results and Have you compared your results with these results? That's lovely. Okay, so I think I have something to share with you. Okay, so there is a book here. In this book, it has an introduction to all PSM method. You see, exercises, propensity score. Did you say this? You say, satisfying the balancing propensity, average treatment effects using nearest neighbor matching, average treatment effects using stratification matching, average treatment effects using reduced matching, average treatment effects using kernel matching, shrinking robustness of average treatment effects. As I mentioned that nearest neighbor matching, radius matching, kernel matching, they are just a common one, but we have more approaches that can be used to generate the treatment effects. Okay, so you say here you can follow these instructions to practice. And if you want to write a thesis using the approach, so you can learn from this data set. I'm trying to find a way where you can download the data. Oh, Indonesia. I think there's a place that allow you to download the data. Let me try to find it. And then you can practice it, especially for students. And how many papers do students have to publish before they finish their master?
Only one.
Oh, that's
Only one
lovely.
paper.
Only one. And what's the name of a master program in Indonesia?
Agriculture, economic, and also
No. How many years?
2 years.
Huh?
Minimum 2 years.
Minimum 3 years.
2 years.
Oh, minimum 2 years. Sodic, you are using a shared office.
Pardon?
You are using a shared office. I saw someone in your office as well.
Yeah. Their office. No, my friend come here to join this meeting as well.
Oh. Yeah, and I'm trying to find ways to download the data for this book. This book is very popular. But definitely students can apply these approaches in their thesis writing directly. I got my data, but I need to find ways to download the data and the data commands. Oh yeah, did you see it? Introduction to data. On page dataset used for data exercises. In chapter 11, go to this website. In the lower right-hand corner, under resources, click people and bios, research stuff. So that means in this website, you can download the data. This location has the original full data set and the subset file which pertain to the exercises. Good? Yeah, so you know where to download the data and to do the practices. Okay, so this is related to PSM. And I'm trying to find the data. I'm trying to find my data documents. Oh, useful data command. You say, Sodic. You say I got lots of useful data commands. Yeah. Uh, uh. Okay, so here, did you remember the commands we practiced? TE, AIPW, IPW, IPWRA, RA. Did you see this? Yes. And you can practice. I can share these two books to you, and then you can share it with the students to practice further. So if students can understand these approaches, definitely they can apply. You say here, use this one is to get data directly. So here it estimates ATE. If we want to estimate ATT, so after the bracket here, we use comma ATET. ATE. Yeah. Yeah, you know how to do the calculations and yeah, and also you can also learn these approaches. For example, for Sodic, when you collect data, you can collect data about the survival time to use these approaches. For example, for survival time model, when you collect data, you will ask. So normally we just ask whether you have adopted a technology. For example, whether you have used the internet. Okay, so that is one question. But for the survival time, like we will ask, in which year were you aware of the new technology? In which year will you adopt the technology? So for example, you are using the WhatsApp. Firstly, you are aware of the WhatsApp, and then sometime later, you will adopt the technology rather than adopt it immediately after you understand it. Okay, so I will share this with you. And someone also asked, and I don't know whom, for no, that nice boy. Ferdout. Oh yeah, Firdaus. Was he asked the question when we have multiple choices, or someone else? He asked that question. Yeah. Okay. Yeah. Okay. So here, did you say the command? Multivariate treatment effects. This model is used to calculate the treatment effects with more than 2 choices. Is okay?
Okay, Professor.
Yeah, this is a multivariate treatment effects. So for example, Firdaus have at least 3 options to study in university. You can study your master degree at UB. You can study your master degree at Lincoln University, New Zealand. You can study your master degree from University of Tokyo, Japan. You have 3 options. So people have 3 options or more than 3 options. And then we can compare which one generate the best outcome. For example, which university can help you to get the highest income from your job. So you can use this approach, that is a multivariate treatment effects model. Okay, so as I said, this non-parametric model, let me share with you the documents. I'm not sure whether I can directly share with you the documents through the chat here. Let me check. Oops. Oh yeah, I can. Oops. Yeah. So can you? Yeah, I have already attached you the paper here, the book here, and then you can download it and try to practice it. Okay. And the second one is oops. This one. Yeah, it's coming. Let me also send it to Sodix's email. Let me also share it with Sodic. Oops. Sodic. And also this one. MOH. Okay, so I have also emailed you the 2 documents, Sodic.
Okay, thank you, Professor.
Okay, so do you have any questions so far? If you do not have any other questions, you can just practice these commands as your homework, or you can practice PSM match. Did you remember? We still have another practice called PSM match.
Yeah, using logic.
Yeah. Yeah, PSM match. Okay. Do you think it's okay? We stop here, Sodic.
Yeah, it's okay, Professor. Before we stop, I think that is there anyone to have a question?
Yeah, and the students can practice these commands.
Yeah.
And if they have questions, they can ask on 30th of July. That is the next Tuesday.
Okay, Professor. It's okay. We can stop here.
Yeah, and in next presentation, we will talk about parametric approach.
Yeah, using instrumental variable, right?
Oh yeah, with instrumental variable.
Okay. If you want.
Okay, thank you. That's all for today.
Thank you very much, Professor Wanglin Ma, for your sharing and lecture in this section. We have talked about the impact evaluation using parametric growth with ISM, regression adjustment, IPW, and you all need to run uh, this PSM model approach using data and using data that Dr. Wanglin Ma have shared previously. Thank you very much, all the participants for the participation, and also the Professor Wanglin Ma. Thank you so much for your sharing. This is very valuable.
It was stuck. Okay, thank you. Bye bye. See you next week.
Okay, thank you, Professor.
Yeah, thank you.
Materinya saya share ya, di share di Google Drive tadi.
Bukunya, Pak.
Oh iya, sama bukunya saya share di Drive. Udah dapet linknya, Bu.
Ya, tadi sudah ada di chat.
Oh iya, saya share. Baik,
Terima kasih, Pak.
terima kasih. Assalamualaikum.
Salam.